Hey mathematicians, here are your notes for 6.4 day 1, talking about compound inequalities. Quick bell work, write an example of a multi-step inequality. If we remember from our last lesson, multi-step is anything that's just more than one step. So, while there could be a lot of examples, my example is going to look like this. I'm going to do x divided by 2 plus 3 is greater than or equal to x minus 5. And then, of course, I could solve that if I wanted to. Be a little tricky, but I think we could do it. Today, we're going to be talking about compound inequalities. So if a multi-step inequality is multiple steps, compound can't mean multiple steps. It has to mean something different. So consider this. An elevator built for a building must be greater than or equal to floor 0 and the top floor. For a 20-floor apartment building with no basement, we can represent the elevator reaching all of the floors between the ground floor and the top floor. What's a short and concise way to represent the building? Well, let's say that F is our floors. We know that our floors have to be greater than or equal to the ground floor, which we said was floor 0. But our floor also has to be shorter than the top floor, and the top floor was 20. So floor has to be less than or equal to the 20th floor. The cool thing about this set of inequalities is that I can actually merge them, but I have to be careful. If F is greater than 0 and less than 20, I can put F in between those two values. It's in between floor 0 and floor 20. The only thing is, now that F is no longer on the left side of an inequality, I have to be careful which way I write my sign. So I know that floor has to be greater than 0, so I'm going to make sure my sign says that it is greater than or equal to 0. But it's less than or equal to 20. That one didn't change, so I'm still going to write it this way. Notice, my signs go the same direction here. And they have to go the same direction because if I put them the other way, say this sign was flipped, it would say that F is less than 0 and less than 20, which doesn't make sense. You can't have a floor less than 0 if it doesn't have a basement. So, make sure that when we're writing these, those signs go the same way. There should never be a time where I see a compound inequality where the signs go in different directions. Quick vocabulary. Compound means that it is made up or consisting of several parts. Made of or consisting of several parts. Which makes sense when you consider the compound inequality that we just wrote. Because it consists of not only the ground floor, but the top floor, it's made of two parts, so it is compound. Therefore, a compound statement is two statements, including the words and, or. So and means both, or is going to mean either. We write and statements like the one above, something is less than something is less than something, whereas either we have to write as two different inequalities, so they are separate. So let's talk about this. If and means that both statements must be true, both or all, whereas only one must be true. Let's try some that don't involve math to start off with. So a triangle has 3 sides and a square has 4 sides. Both of these must be true in order for it to be a true statement. Well, a triangle does have 3 sides and a square does have 4 sides. So both are true, meaning the entire statement is true. A triangle has 3 sides, or a hexagon has 5 sides. Well, the first one is true, but the second one is false. But that's okay, because or tells me that only one of them has to be true. So that makes this statement true. Try the next one on your own. The sky is yellow, or the grass is green. Or tells me that only one of them has to be true, so even though the sky isn't necessarily yellow today, the grass is always green, unless it's fall. And in the fall, the sky is probably yellow. That's probably a bad example, but we get what I'm saying. So this is a true statement. The next one says a horse has 4 legs and a duck has 2 legs. Not a question mark, a period. A horse does have 4 legs and a duck does have 2 legs, and since they must both be true because it's an and statement, the whole thing is true. All right, now let's make it a little harder with math. 5 is less than 4, or 6 is less than 8. The first one isn't true, but because it's an or statement and the second one is true, the whole statement is true. 4 is greater than 0, and -4 is less than 0. It's an and. Are they both true? Yes, so the whole statement is true. This one is 3 is less than 4, and 2 is less than 2. They both have to be true for the statement to be true. This one's true, but that one's not. So the whole statement is false. What does this look like with regular math, Miss Bray? Is this just going to be a true-false test? Good question. The answer is no. Special case. Compound inequalities containing and. Given the inequality x is less than 3 and x is greater than or equal to -2, what is this telling us? Well, let's graph it. I find my 2 important values. The first one is 3. The second one is -2. X is less than 3 means I circle at 3 and go to the left, but don't fill in the arrow, don't fill in the dot. X is greater than or equal to -2 says I find -2, fill in, and go to the right. Now I notice those two are going to collide. So you'll notice the graph of a compound inequality containing and is the intersection of the graphs of the 2 inequalities. And in other words, both statements must be true. So this is why and they both have to be true, because they have to come together like this. And together or out. So if you have any questions on this or graphing your compound inequalities, don't hesitate to let me know.